Hi, welcome to Physical Science and Physics on the Scientific Method. Welcome back to second semester. The scientific method has 6 primary parts. Part 1 is the question or the problem. This identifies what you are testing. Part 2 is the research, the background information about the issue at hand. This is not the experiment. This is what you already know about what you're doing. Part 3 is the hypothesis. This is a prediction that answers the question you started with, and it has to have 2 primary parts. It has to be testable, and it has to be written in if-then form. Part 4 is the experiment, that you actually conduct an experiment. There are 4 parts to this experiment. The procedure, these are the steps of the experiment, and they have to be very, very detailed. The factors, the variables, constant, control groups, etc. Observations, remark or statement about the comment based on something you see, hear, or even notice. And some inferences, a conclusion reached on the basis of the evidence and reasoning. Now notice that's all part of the experiment. Also notice that factors and observation, those have little asterisks by them because they have separate things that we're going to talk about that you're going to write at the bottom. Part 5 of the scientific method is the conclusion or the graph. This is where you analyze your data. This is the summary of the data, the results, and it must refer back to your hypothesis and include any source of error. Where could you have made a mistake? Finally, part 6 is report your results. This is going to become a theory or a law, and we will talk about those separately. And this is how scientists research. So let's look at those factors in the experiment. First, you have the independent variable. This is the factor that is changed by the experimenter. Now, most of the time for us, the independent variable is time. Right? We had velocity time and acceleration time and distance time. The dependent variable is the factor that changes because of the independent variable. It is the measured factor. So whatever you're trying to measure, that's your dependent variable. The constants are the factors that remain the same. We're not going to change this. And then finally, the control is the part of the group or the experiment that is the norm that you're not going to do anything to, you're just going to use it to compare. You then have 2 kinds of observation. You have qualitative that deals with descriptions. It's data that can be observed, not measures, like colors and textures and smells and tastes. Okay? Qualitative comes from the word quality. Then you have quantitative data. This deals with numbers, data that can be measured, length, height, area, volume, all of those things. Quantitative comes from the word quantity, meaning a number. Then finally, we talk about a theory or a law. A theory is an explanation of things or events that results from years of testing, but it's not actually proven. It's a theory of relativity. A law, however, is a statement about how things actually work in nature, and they're almost always true, like Newton's laws of motion. That's why they're laws and not theories. The second part of this is direct and inverse variation. We did a lot of this first semester, so you may not need to write this down. It's just kind of a recap. Direct variation first. When we talk about direct variation, we're talking about relationships where as one value increases, the other value increases, or they both decrease at a constant rate. Each variable does the same thing. So direct variation uses that formula, A is equal to BC, where A is directly proportional or related to both B and C. Inverse variation is similar, but in inverse relationship, one value goes up, the other goes down. This is not necessarily at a constant rate, but could be any form of variation. In inverse variation, if you have that same formula, A equals BC, B is inversely proportional or related to C. First semester, if we put all of our first semester formulas into that format, you can quickly see the direct and inverse variations. So remember, distance equals velocity times time, change in velocity is acceleration times time, F equals ma, P equals mv, and even Eg and Ek can be used with this direct and inverse variation. All right, you're going to be working on scientific method things today. Thanks for watching.